this. I don't know if it's recording. Oh, it looks like it is recording. Okay. So it looks like it is recording. I have no idea where it's going to go, but whatever. Okay, so I'm back again. I apologize. So we are back to this. And right now, as I said, we are doing a quick review on evaluating some laws of exponents and things that we need to do. Let me know when you kids are all ready and set to go, and then we can go ahead and do that. Now, while you're waiting, for those of you who are like, this is super, I'm fine, I'm ready to move on to the next thing, use your time wisely. You know, I want you to create a table to graph the function f of x equals 2x, starting with, you know, it going from like -4 all the way down to +4 when you plug that in, okay? So -4, using integers, so -4 to +4, I just want you to graph f of x is equal to 2 to the x power. When you are done with that, okay? So those are the 4 things. So I guess number 4, I should have said sketch f of x equals 2 to the x, blah, 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 but it's okay. This is just giving you guys an opportunity. And if you want to think out loud and talk to other people in the class, this is the opportunity for you guys to do that. It's almost like I'm trying to simulate being in class right now. Can I get a thumbs up from you guys telling me that, yes, I'm with you on that C-Schwa? All right, awesome. I see some of them. Good. So you can either give me,
go
ahead.
Can we annotate this page, like the shared screen?
Can we what?
Are we allowed to, like, are we able to annotate this screen right here, like the one you're sharing with us?
I don't think you are. I don't think you can.
Oh, wait. Oh, I think I can.
I think you can.
Yeah, I can. Yeah.
Oh my God, you guys can annotate on here?
Yeah.
Yeah.
Oh my God, this is amazing. Oh my God, this is absolutely positively amazing. Hi, Sarah Kelly. I see you're joining us, sweetie pie. You have no idea how excited I am to hear that you guys can annotate anything that I have on my screen. God, that's awesome blossom, which means you guys can fill out those answers as if you're going to the board to do it, which is fantastic. Awesome. This is very exciting. Wow, so it doesn't just have to be on the whiteboard. Wow, that just opens up a whole new world here. This is a brand new world. It is on, friends. It is on. Now, how many of you were able to actually write on the screen neatly? Do you have a tool that you can use to write on the screen neatly like I do?
No.
Like
I
my
wish.
little pen, the pen that I have, you know?
I think the fat marker is a little bit easier to write nicely with.
Okay,
Just
that's cool. Because we're all in this together. We are a family. So as a family, we are in this together to figure out what we're doing. Look at you. Is that you, Aaron? Was that you with the thing? Did you do the
yeah,
fat marker? Good for you. Okay, awesome. All right. How many of you have gotten through 1, 2, and 3, and now you've begun to work on number 4?
Wait, are we graphing number 4?
Well, you're filling out a table first. I just need you to fill out a table first. Like if you're going to do a table of values, like you have to do 2 to the -4 and like whatever. I would start with the positives and then kind of work your way back, you know? Yeah. Okay. How many of you have finished 1, 2, and 3? Give me a thumbs up on your screen so I can see. Give me thumbs up with your hands or put the little reaction thing up there so I can determine who's done and who's not done with 1, 2, and 3. Okay, so since you guys are able to annotate, so because you guys are able to annotate, Nate, can you put number 1 up? Number 2, Jolie, and then number 3, Amanda, can you put up number 3 for us?
Wait, which one am I doing?
2.
Okay.
Okay, so are you guys able to annotate?
Yeah.
Okay, good. And what is 2 to the 6th on number 1?
That would be 64.
Okay. And who's got, Amanda, are you able to do number 3, honey?
I didn't do number 3 yet.
Does somebody have number 3 done?
Yeah, I have number 3 done.
Billy, can you put up number 3, hon?
Yeah, sure.
Okay. Billy, I like that you're showing us how you went about that, right? I like that. Because I'm going to jump in here too, because I can. Oops, sorry, that's me jumping in here. When you have this right over here, it's basically saying you're doing 4 to the 3rd over 5 to the 3rd, which is the same thing as doing 4 times 4 times 4 and 5 times 5 times 5. So, and I like, Billy, that you are showing out how you're doing each individual one. Good. Give everybody just a moment to go ahead and do that. So then your final answer, Billy, would be?
81 and x to the 8th
and y to the 20th.
and y to the 20th.
Awesome. So when you go back up here, who did I ask to do the first one here? Who's me?
Nate.
Nate. Okay, so Nate, when you realize that when you have, by the way, what are these called, these numbers? Do you guys know what these numbers are called? This. What are those numbers called?
Rational?
No, starts with a B.
Bases.
Bases, very good. So when you have a to the x power, this guy is called the base. This guy is called the exponent. Okay? So to start off with, that's exactly who we are talking about. So that's your base and that's your exponent. So when you have the same bases, so the key is it's always knowing your language. You have to know the language. So when we did the 2 squared times 2 to the 4th, Nate realizes that when you have the same bases, what can you do to your exponents?
Add them.
You add them. So if I have a to the x times a to the y, it's going to be a to the x plus y. Okay? When we have anything cubed inside this is basically saying that everybody's cubed. Over here is so much more interesting. Like Billy actually jumped a couple of steps because he can, and he did -3 to the 4th and then times x squared to the 4th, because it's saying everybody inside the parentheses is being raised to the 4th power, right? And when you raise a power to a power, what do you do to the exponents?
Multiply?
You multiply. And the reason why you wind up multiplying is because when you have x squared to the 4th power, it's kind of like what Jolie showed over here. Let me move this out of the way because I can see you guys. Okay. It's like saying x squared to the 4th is equal to x squared times x squared times x squared times x squared, right? Because it's saying you're multiplying this thing times itself 4 times. And going back to what Nate said, you add the exponent, so that would be x to the 8th power. But to cut it short, all you do is multiply your exponents. So if you have like a to the x to the y power, you can write that as a to the x times y. Okay? Does this look familiar to some of you?
Yeah.
Okay, good. All right, so now getting into, oh, how interesting. You guys, your stuff is still there. If I do a new page after you guys annotate. How do you make that go away? Hold on. Ooh, I wonder if I can.
Oh, we can erase it.
I
The
wonder
person themselves
Yeah,
has
wait
to
a
erase
minute.
it.
You probably press clear.
Press clear, it gets rid of your stuff.
I don't have a clear thing on mine. Did you guys just clear it up? Thank you. Okay, awesome. All right. So now the next thing that we were talking about is we were talking about doing f of x is equal to 2 to the x power, right? So we know the base of this is 2, right? And the exponent's 1. So if we were to do -4, -3, -2, -1, 0, 1, 2, 3, and 4, I always like to start with the positives because they tell a beautiful story. What is anything to the 0 power? So if I were to do 2 to the 0, what would I have, gang?
1.
1.
You get 1, good. And then 2 to the
Why is that a thing?
What is that?
Why is that? How does that work out?
So the reason why, I think I showed you guys this earlier on in the year, but I'm ready to show you now. If you were to take something like 2 divided by 2, what does 2 divided by 2 equal?
1.
1, good. And this is 2 to what power, friends?
The first?
First. This is 2 to the 1st power. Now, so before, when we said that when you multiplied the same basis, right? If I have a to the x times a to the y, we had to have a to the x plus y. So when we multiply the same bases, we add the exponents. So when we divide the same bases, we would simply subtract the exponents. Good. So this I can rewrite as 2 to the 1 minus 1, right? I'm not doing this. I'm just carrying the 1 down, right? Because I can go ahead and write this. And what is 2 to the 1 minus 1?
0.
2 to the
0. And that is why 2 to the 0 is equal to 1, is because we're using laws of exponents that if I have a to the x over a to the y, this is the same thing as a to the x minus y. So it's using that rule.
Oh, okay.
Thank
That
you
makes
for
sense.
asking. Now, that's a great question, Billy. Thank you for asking. I want you guys to keep throwing questions. I love it. Okay, so we know
So
that
for every exponential function, is the y-intercept going to be 0, 1?
not always, because the thing is in some instances, because what if I had, and that's another great question. So if I had y is equal to, like, say, 3 to the x plus 1, what's the y-intercept going to be here?
2.
2.
2. So now there's a perfect example that contradicts that the y-intercept isn't always going to be 1. You know what I'm saying? Or even if I had, check this out, what if I had like 4 times 2 to the x? Okay? If I did 4 times 2 to the x and I said, what's the y-intercept? You're going to do 2 to the 0, which is
1.
1, and then times 4 is 4. So here are 2 examples where your y-intercept isn't going to equal 1. Okay? So just keep all that in mind, that you're going to have to do evaluating and all that in those beautiful minds of yours to do this. Okay, so what's 2 to the first? We all said was 2, right? If I plug 2 and 2 squared is
4.
4, 2 cubed is
8.
8, 2 to the fourth is 16, and so forth, right? But if we go backwards, so if we look at these numbers, if I keep going backwards, right? 16 to 8 to 4 to 2 to 1, what are we doing?
Nothing.
Doubling.
Well, we're going the opposite. Well, if we go 1 to 2 to 4 to 8 to 16, we're doubling. But if we're going in the opposite direction, what can I predict this value is going to be if it's 16 and then 8 and then 4 and then 1?
One half.
Yeah,
1
half.
half.
Exactly. This is going to be
1/4.
1/4. Isn't that interesting? This is going to be
1/8.
and this is going to be a 16th, right? So what that's saying is, let me just get my little eraser here. So that's super interesting, right? So with that said, so when I go ahead and I'm looking at all that, this is basically saying then over here that 2 to the negative 1 is equal to 1/2. This is saying that 2 to the negative 2, I'm sorry, what did I just do there? That's a square root. That's a completely different animal. Okay, so 2 to the negative 2 is equal to 1/4, right? 2 to the negative 3. What is 2 to the negative 3, everybody? It's 1/8. Isn't that interesting? So, and it goes back to saying, like, how, if you wanted to rewrite that, that's letting you know that when you have negative exponents, that means then, what would I rewrite this as before I turned it into 1/8? I can turn this into
1 over 2
2 to the
to the 3rd.
1 over 2 to the
2 to the
third.
third.
Yes. I can take 2 to the negative 1. I could take 2 to the negative 1, and I can rewrite that as 1 over 2 to the first
2 to the
power,
1.
right? I could take 2 to the negative 4, and I can rewrite it as
2 to the
1 over
1
2
over 2 to the 4th over 2 to the 4th.
awesome. So yet another. So let me go to a new page. So right now we have that, whoops, that a to the x times a to the y is equal to a to the x plus y, right? We know that we have a to the x raised to the y power is the same thing as a to the x y. And we know that a to the x divided by a to the y is equal to a to the
X
X minus y.
beautiful. And now I can say that a to the negative x is equal to
1 over 8 to the x.
Ah.
1 over a to the x. Isn't that awesome? And this, by the way, came from like an implicit and logical space where you go back and you look at the function, and the function is telling you, use the number patterns to tell you that when you raise a base to a negative power, what happens to that power. Isn't it delicious that you can actually use a function to help us do that, which I think is absolutely beautiful. Give me one of that clapping thing, or give me a thumbs up if you guys are like, yeah, that is kind of cool, Schwab. Play the game with Mama Schwab. Thank you. Some of you are doing it. I appreciate it. Okay. Bravo. Okay. So now when we go to graph this exponential function, I know here like 1, 2, 3, 4, 1, 2, 3, 4, right? I know at 0, I'm over here at 1. At 1, I'm here at 2. And then at 2, I'm at 4. You can see the sucker is growing, right? Growing, growing, growing. But when I go to the negative side, if I plug negative 1 in, I had negative 1/2, then it was negative 1/4, and then this is negative 1/8, negative 1/16. So if I said to you guys, would you agree that this function has an asymptote, right? Because if you think about it, if you keep going, right, we had 1/2, 1/4, 1/8, keep going, 1/16. What's next?
132.
132.
Second, followed by
164.
128.
128.
All of those numbers are
156.
approaching 0. So when we look at y is equal to 2 to the x, right, we know that we have an asymptote, right, at y is equal to 0, right? Everybody, because the graph is trying to get there. So if I said to you, what is my domain and what is my range, what would you kids tell me?
Domain is all your
Domain X
numbers.
is greater
Range
than
is greater
0.
than 0.
0.
Right.
Range
This
is
y
greater than 0.
greater than 0. So in other words, x can be anything it wants to be, but the y is saying, all right, I got to be bigger than 0 because I'm never going to get there. So this is an asymptote that we don't cross. Okay. All right. I got something for you guys to test out. So let me see. Nope. Keep going. Keep going. Got those cute rules. Okay. Right over here, we know what f of 2x looks like. F of x equals 2 to the x looks like. If I wanted to find out what f of x plus 1 and f of 2x look like or what they were, do you remember what to do when we have something like f of 2x, f of x plus 1? Do you remember what we would do with something like that?
Yeah.
Yes?
Back and
Everywhere I see an x, so if I have f of x plus 1, I look over at the function here, and everywhere I see an x, I substitute in
X
x
plus
plus
1.
1.
1.
Would you guys agree then it would be this? And then if I had 2 times f of x, this is saying you're just multiplying the function by
2.
2.
Are these the same thing? I guess the question I want to know is, are these the same function? So if I shift this to the, because what is the, by the way, what is the transformation that has taken place on this one?
The
Addition.
horizontal shift to the
Oh,
Horizontal shift to the
left.
left.
Beautiful. What is this one saying you're doing?
That'd be a,
Making it narrow, making
Yeah.
it narrow it.
And what are you
narrower.
physically doing to all your y coordinates?
Doubling.
Multiplying them by 2.
Multiplying them by 2.
Now my question is do you think that those are the same?
no.
Yes.
No.
Yes. Yes.
Oh, I got some yeses. I got some no's.
Yes.
So I'm going to go ahead and pull you guys over. So for those of you who think it's a yes, that they are the same, give me a thumbs up with your reaction. Okay, so some of you said yes. And then some of you were like, I don't think so. Let me go over here so I don't forget everybody. So some of you said yes. So whoever said yes, so going back to somebody who said yes, can you do the thumbs up for me again? Because the thumbs go away pretty quickly. So annoying. Awesome. All right, so Sonia, can you show us why those are actually the same function?
Yeah, so if you look at the first function, 2 to the x plus 1.
Can you annotate?
Yeah.
Okay.
I think I have it on. All right. So when it's like if you go back to exponent rules, you can break down 2 to the x plus 1 into 2 to the x times 2 to the first. And then 2 to the first is 2. So essentially, what happened? Oh yeah, 2 times 2 to the x, which is the same thing that's happening in this function.
Isn't that interesting? How many of you who did not have a thumbs up before are looking at that now and saying to yourself, self, that's pretty interesting. Can I have a thumbs up from those people? Awesome. All right. That is interesting because if you use your laws of exponents, because the thing is, remember what I've said to you guys all year long, simplify, simplify, manipulate, simplify, simplify, manipulate. I've been annoying with that, have I not? You can all nod your heads, it doesn't offend me because I know it can be annoying, okay? Thank you. All right, so what about this one? So what about this one? So using the same function, 2 to the x, I want you guys to evaluate or, simplify to tell me if I do f of x to the minus 2. That always happens. Let me just go here. Okay. Stop. All right, here we go. That's better. All right. That if I were to go ahead and do f of x minus 2 versus f of x over 4, would, shifting to the left 2 and then dividing all the y coordinates by 4 yield the same exact function if our function that we're using is f of x is equal to 2 to the x power? So again, if I want to do f of x minus 2 versus f of x divided by 4, go ahead and do your magic and let's see what happens. So why don't you guys start working on that and start using, and then again, simplifying your exponents and doing the things that you need to do to see if, hey, that does work, or hey, no, it doesn't. And then after that, I'm going to add another question. This is driving me nuts. And I'm going to ask another question after that. And then my second question, for those of you after you finish doing the first one, and again, it's all about being able to manipulate functions and using your laws of exponents to show if something is equal. Would f of quantity x minus 3 equal f of x divided by 27? Oh, internet, stay with me. Don't get all crazy. There we go. Okay. Can somebody show us if f of x minus 2 is the same thing if f of x is over 4? How many of you said it was? How many of you, with a show of hands, say it is? Good. Barak, can you show us why? Can you annotate and show us why?
Sure.
Okay.
Okay. So. Okay, so essentially, f of x minus 2 is
Can you annotate on the screen, sweetheart?
yeah, sure.
Okay.
Sishwa, I have another call to get to right now for history.
Yeah, same.
Yeah,
For those of you who have to go, thank you. I just realized we are already over. We're almost done, but you guys go ahead and go ahead on out. I am recording, so I will put the video up for it, okay?
All right, bye.
Bye.
Thank you.
Bye.
Thank you.
Guys for going over. I can't help myself. Okay. For those of you that are still here, so go ahead. Barak, keep talking, buddy, because I like what you're doing.
So, and we know from our rules that we're allowed to, that's basically just 2 of x over
A 2 to the x.
2 to the x
There you go.
over 2 to the second power.
Now, how did you jump? You jumped a big step. What step did you jump that I am like, wow, you're a rock star for jumping the step, but you did jump the step. So I'm going to come in here and just give you a hand. You said you can rewrite this as 2 to the x times.
Oh, yeah. 2 times 2 to the
2 to the negative 2, right? Because you can use your laws of exponents, right? When you multiply, you can always go back. So in other words, that law, that rule, you can use in either way that you want to. And then you realize that this is the same thing as 1 over 2 squared. So then when you simplify that, you get?
you get 2. Yeah, exactly.
Which is what I got over here, because all I'm doing is taking the function and dividing it by 4, right? Yeah. Now, anybody, if we're looking at f of x minus 3 equals, does that equal f of x over 27, right? If we were to do the same thing, what would you chucklehead say? Would you say it's the same thing, yes or no?
No.
No.
Really? So let's do it. So actually due to the, go ahead and we'll see if you're right in a moment. And we'll see if you're right. And you can tell me what it should equal. What the hell about this? How many of you said no? Who said no? Raise your hands. Good. What should it equal? Like f of x minus 3 would equal f of x divided by what?
8, because it's 2 to the third power.
Yes, good. Because again, you can write 2 to the x minus 3, right, as 2 to the x, talk with me everybody, times 2 to the
2 to the negative third.
3, and then that I can rewrite as 2 to the x divided by 2 to the third, which is equal to 2 to the x over 8. So awesome. So that would be over 8 in order for that to work. Isn't that just delicious? I just feel like when you're able to manipulate and use your laws of exponents, it's going to help you do that. So now what I'm going to do is I'm going to stop sharing this screen, but I want to show you one more thing before I send you guys off into the sunset and we call it a day. And again, thank you so much for your patience. I really appreciate the fact that you guys are doing that. So let's see, is this you guys? Nope. Is this you guys? Is this you guys? Yeah, nope. Oh my God, eventually I'll get to the right class. Can you guys see this?
Yes.
Yeah, you see what I'm doing? I'm on Canvas. Everybody with me?
Mm-hmm.
Yeah.
Okay. So the thing is I did, so what I did here was right here, we went over numbers 1 and 2 together. And I even added that extra problem. So for today, when you and I hang up, you're gonna go ahead and do the same thing for the function. By the way, what would be the difference between 2 to the x and 1/2 to the x power if you were to sketch that?
Go the other way.
It would go the other way, exactly. Because, oh, come on, internet, stop being all crazy. Because this
Because of
represents exponential growth, but this one represents exponential
Decay.
decay. Because this is saying your numbers are doubling. This is saying that your numbers are
Okay.
half the size of what they were. Very good, okay? So if you look at this, so what I'm doing is in number 3, that's what I want you to have done by today, by 7 o'clock. And then number 4, I gave you an assignment that there's 8 problems on. The first 4 are due tomorrow. The second 4 are due on Thursday, okay? So I'm trying to, so what I'm literally trying to do is I am trying to spread everything out for you guys so it's not so overwhelming and you have time to do it and you can ask me questions. That's the other thing. You can reach out to me if you have questions in that time to say, I don't understand number 7 or I don't understand whatever. And we can kind of take it from there. Okay. Are there any other questions, my dear friends? And again, thank you so much for coming and I'll see you soon. All right. We'll see each other, I think, on Friday.
Thank you, Cishwa.
All right. Thank you guys. You are the best. Bye.
Bye.